Welcome to This Explainer. You know that feeling when you plan a weekend out and the weather forecast ends up being completely hilariously wrong? Well, now imagine trying to predict the weather for over 1 billion people. Today, we're exploring how India transitioned from battling a billion-piece meteorological mystery to achieving true supercomputing sovereignty and AI-driven precision. It's an incredible story of cutting-edge tech meeting the ancient forces of nature, and we're going to see exactly how they're pulling it off.
So let's jump right in with a seemingly impossible question. How on earth do you predict a chaotic weather system that's driven by land temperatures, Himalayan snowpack, and soil moisture? A system that, by the way, brings 75% of India's annual rain and sustains well over 1 billion people. Honestly, it's like trying to solve a puzzle with 1 billion moving pieces.
That brings us to Section 1, the billion-piece monsoon mystery.
There's this really fascinating contrast between how we used to do things and how we do them now. Historically, meteorologists relied on numerical weather prediction, or NWP. Basically, these models chop the globe into 3D grids and crunch zillions of complex physics equations. The catch? Their reliability really taps out at about 5 days. But on the flip side, modern AI models don't just sit there crunching equations. They actually recognize historical patterns from decades of data, which keeps them remarkably accurate for up to 30 days ahead. It's a real game changer.
Moving right along to Section 2, Supercomputing Sovereignty, featuring PARAM Siddhi 2.0.
To actually achieve this kind of supercomputing sovereignty, India launched a series of systems that culminated in the massive PARAM Siddhi 2.0 architecture. We are talking about speeds peaking at 5.267 petaflops. Just to put that into perspective, a single petaflop is 1 quadrillion calculations per second. This indigenous powerhouse absolutely skyrocketed India, sending them straight to the 63rd spot on the global top 500 list.
And you literally cannot pull this off without some immense hardware. Picture these incredibly dense compute nodes packed with 336 NVIDIA A100 GPUs. All this raw parallel speed means researchers can run countless experiments at the exact same time. It allowed India to finally build its own hyperlocal climate models without having to outsource the heavy math or rely solely on foreign data processing.
Which brings us to Section 3, AI-driven weather wizardry.
So how does this AI wizardry actually work? Well, it happens in a really fascinating 3-step sequence. First, the system ingests these broad, global AI forecasts. Second, it applies what are called super-resolution neural networks. Think of this like taking a blurry, zoomed-out photo on your phone and using AI to magically sharpen it so you can clearly read a license plate. And third, it downscales that broad info into incredibly precise, hyperlocal, block-level rainfall data.
But, here's a pretty fascinating twist. Because AI isn't actually constrained by the physical laws of the universe, feeding it only past data can sometimes lead it to hallucinate unrealistic extremes or stumble on rare edge cases. To fix this, researchers use hybrid models. These hybrids basically grind through the big atmospheric physics equations first to set the reality boundaries, and then they use AI to seamlessly and rapidly fill in all those granular details.
Let's look at a real-world example in Section 4, predicting the Mahanadi floods.
When severe weather events hit the massive Mahanadi Delta, these AI simulations absolutely prove their worth, predicting severe floods an incredible 7 hours early. Now, in the high-stakes world of disaster management, 7 hours is quite literally the difference between life and death. That is enough time to evacuate villages, move livestock to higher ground, and secure critical infrastructure. And we're seeing this officially documented too. Government reports show AI is stepping up to support everything from bias correction to hyperlocal cyclone tracking. It's even translating complex monsoon advisories into regional languages through an AI tool called Bashini. That means critical early warnings are being delivered directly to rural farmers in a language they actually speak. All of this is powered by the new Bharat forecasting system, which maps the atmosphere using a highly complex 3D geometric grid. Thanks to this, India is now the only country on Earth providing operational forecasts at an unprecedented 6-kilometer granularity. We are pinpointing weather down to the size of a local village.
Which leads us perfectly into Section 5, empowering 38 million farmers.
Just think about this number for a second. 38 million. That is how many farmers receive these new AI-generated forecasts. Imagine the sheer logistical triumph of getting hyperlocal, block-level weather data directly into the hands of 38 million people. It completely empowers them to make highly informed, life-changing decisions about their crops and their livelihoods. The economic impact here is just staggering. For instance, the AI model successfully predicted a massive 20-day stall in the monsoon, a sudden dry spell that the traditional numerical models completely missed. Because of this early warning, almost half the farmers adjusted their planting schedules. Researchers are now estimating a potential $100 return for every single dollar invested in this forecasting initiative. That's huge.
And that sets the stage for our final section, Global Climate Intelligence Leadership. This whole journey is leading to what experts are calling a true democratization of weather forecasting. And the reason is simple but absolutely brilliant. Because these AI models, once they're initially trained on a massive supercomputer, can actually be run on a simple high-end laptop. That completely opens the door for developing nations who just don't have billions of dollars to spend on their own ongoing computing infrastructure. Motivated directly by India's success, investments are now pouring in from around the globe. Supported by organizations like the Gates Foundation, this exact AI wizardry is expanding to 30 other countries right now. They're actively benchmarking models to bring critical heat wave and rainy season predictions to highly vulnerable populations across East and West Africa. So, that leaves us with a really provocative thought to wrap up this explainer. As our supercomputers and hybrid AI models finally begin to master the ancient, incredibly chaotic mystery of the monsoon, what other unpredictable forces of nature will we tame next? Thanks for joining me on this deep dive, and keep questioning the world around you.